Okay, in this tutorial we're going to be creating some electrical explosion sparks. Now what I mean by that is basically a nice kind of shower of sparks when like there's a short circuit or like a transformer goes up, that kind of thing. So you've got these nice kind of trails of sparks flying out, and this kind of standard like almost U-shape emission that kind of flies out from our emission point. This is basically going to be our emission point in our scene here. So this can also be attributed to welding sparks. The kind of distribution is very, very similar. Like for example, when either a MIG welder or a oxyacetylene torch is blasted against a metal surface, you get this kind of repulsion and friction and sparks kind of flying out in a similar kind of pattern. So basically, because these kind of electrical sparks are very kind of difficult to source with regards to reference. I mean, one good idea to actually source them would be to have a look at some pyrotechnic work within some like the most recent movies, like for example Transformers or Iron Man, that kind of thing. They get some nice these kind of like nice U-shaped horseshoe flares and spark emissions coming from their explosions. So what we're going to do is have a look at some of the basically some welding footage. Let's just pull one of these guys up for starters. Let's have a look at this one here. I'm just going to drag that across, wait for it to update. So wait for him to get out of the way. All this footage and images come courtesy of iStock Photo. So let's just go back through that again. So if I just skip through here, so we can see here we've got like the torch is basically being blasted down to this metal surface, and we've got a few individual trails which are kind of scooting off here and ricocheting off this metal surface, but you've also got this kind of nice arc going on here, which you can see around about the emission point. Now this blue emission point here, just going to put a tangent a little bit, we're not actually going to be simulating this kind of blue color here where it's actually blasting the metal. That we'll actually discuss in the taken further section at the end of this tutorial. So the thing we need to concentrate on is basically the motion of these sparks, the arc, the direction, and the speed of them. Okay, let's just bring up another one of these guys. Now this is a nice kind of oxyacetylene torch actually blasting through a metal cable, so you can see the directions actually change as is obviously welding through, as is cutting through this metal cable here. So when you actually blast the underside, we have this kind of nice shower goes upwards, and is obviously almost getting it straight on now, so you get this nice kind of, again, the U shape of the spark emissions here, and also some additional third-party trails coming off as well. So just skip back a bit. It's kind of difficult to find. Okay, here we go. It's quite a nice one. So we've got literally a very kind of fine emission point here. I've got a kind of, it's like a very kind of fine wire that is obviously cutting through. So the trails that is actually that we're basically getting here is not very, very wide, not very kind of like widespread, wide angled. They are very, very kind of localized with some, like I say, some additional third-party trails from fragmentation coming off at the sides here as well. So what we basically need to concentrate here is this kind of emission within our system. Okay. This gives us a good indication of the kind of, here we go, it's a perfect example. So you have these two kind of main directional forces, these two main directional emissions of sparks here and here, with a few, like I say, third party ones. Again, this kind of central flare we're actually not going to concentrate on in the tutorial. However, like I say, we will discuss this at the end of the day. So the thing we need to concentrate on and take note of here is basically spark duration, i.e. the actual length of the spark, and which therefore obviously dictates the speed. The ejection patterns, this kind of nice fine control. And if you notice, we have, like for example, one kind of main spark here, but we've got some additional third party ones, some like kind of smaller child offset emissions here and here. Same deal with this particular set here. So we've got, say for example, we've got one kind of main emission here, which is literally split into like 3 or 4 individual ones. So we've got one coming here, which has got some additional child ones, one main one here, which has got some additional child ones here as well, and this guy here as well, which has got about 1, 2, 3, 4, 5, 6, 7, about 8 or 9 emissions as well, which are basically like a very slight divergence out as well. Same thing can be said down here as well. We've got about 2 from this particular point here, so we've got one coming down here, which has got about 3 or 4. Say for example within like about a 2-degree divergence here, and also same deal here as well. We've got basically about another 2 or 3 additional particles coming off here as well, with about the same kind of 1 or 2 degree divergence as well. So one main reception point for this welding torch, and 2 main emissions, so 2 main ejection points for the sparks. However, these are actually split into 2 trails, which are then in turn fragmented off even further with a very kind of small divergence as well. So it's this pattern, it's this distribution pattern that makes these kind of spark emissions, be it welding or electrical explosion emissions, more realistic when you're actually coming to designing Mini or 3D software. Okay, one last sequence to have a quick look at, which is this guy here, and this gives us a nice indication of the lifespan of the particles once they've actually hit the ground. So if we notice that there's a few trails as soon as like one of these particles, one of these sparks hit the ground, you can tell by the trail length how fast they're going, like I said before, and kind of the amount of intensity. So there is a fair amount of sparks which die almost immediately on impact. You can see once this stops, it kind of dies down towards the end. Let's just skip back there a second. Here we go. So you can see we have about 4 or 5 individual sparks which are basically split off as soon as this particle hits the surface. So about maybe about 5 or 6 even that kind of split off here. And also when they actually hit back down onto the surface, they actually sit there and carry on glowing for a substantial amount of time, quite simply because obviously the material that has been ejected is quite big. The larger the fragment, then obviously the longer the glowing material is obviously going to sit on the surface until it obviously cools down and in essence disappears. So therefore any kind of smaller ones obviously need to have like a shorter lifespan. The same thing can be said about the actual trails themselves. If you've actually produced the angle grinder tutorial before continuing on to this one, you'll notice that in some of this footage you might notice 1 or 2, and just try and find some, depending on the way obviously the sparks are produced. Let's jump back to this guy here. What I'm trying to indicate here is how the actual spark dies. Now we're not actually going to concentrate on the kind of forking pattern that we actually have in, for example, the angle grinder system. If you want to integrate that into this system later on, then feel free, but it's slightly beyond the scope of this particular tutorial. The things that we need to take away from this is obviously distribution pattern, speed of the particles, which can be dictated by this guy here. So they are quite quick. However, depending on obviously the size of the material and the height of the object that's obviously emitting them, then we'll get like a nice kind of flowing pattern of sparks coming off from our emission point, which is this guy over here. Okay, colour, same deal as before. We're actually going to deal with similar colours to those in the angle grinder. If you want to go through and change those later on, again, feel free. Okay, so the scene we're dealing with is this electrical explosion sparks start max scene. Make sure you actually accept any file unit changes when you load the scene in. Reason being is because we're obviously going to be dealing with particles, and we're also going to be dealing with procedural maps. So therefore we need to make sure that the results that you get at the end of the day are the same results that I'm basically narrating in this video tutorial. Okay, so like I say, we've got 3 main objects in the scene. One is our camera, which is tilted up and looking at this emission object here, which is simply a sphere primitive. standard radius at 20, 32 segments. Now what we're going to do is actually going to increase the amount of segments in our sphere primitive here. Reason being is because this primitive is not only going to be used for setting speeds, but it's also going to be used for the emission and obviously berth placement. So what the reason we need to obviously increase the amount of segments in here is quite simply because if we actually had, like, for example, a number of particles born in this particular area, and we're obviously using the surface normals to drive the direction, basically the particles will literally go in that direction and also in that direction, basically because there are only two kind of main faces that the particles would take their trajectories from. So if we actually increase those to, for example, 128 segments, and they're born within this area as well, same area as before, we've obviously got a hell of a lot more particles to actually create this kind of nice curve emission, which obviously aids us in realism at the end of the day. So I'll actually leave that at 128, and what I'm going to do is I'm actually going to rename this guy. Let's call that sphere emitter, and I'm also going to instance this guy and label it sphere speed. Okay, we obviously don't want these guys to render, so therefore let's just select these two objects in here. I'm going to right click, and I'm going to go to object properties and turn off renderable. Okay, the other object we've got in the scene is a standard deflector space warp with just the bog standard bounce and no variation, no chaos, no friction, and the standard value of 1 for the inherent velocity. Quite a large width and length segment values, just so it encompasses the majority of the scene on the floor. So because the spots are going to be flying off in all directions, driven by procedural maps, so we get a nice kind of realistic trail as they're being ejected. We obviously need these guys to this deflector to basically catch the majority of the particles, otherwise they'll carry on until they actually die, which obviously wastes a little bit of calculation time if they kind of scoot over the edge. Okay, to get this kind of like nice realistic distribution that we're referring to in our reference material, this kind of pattern. Come on, where are you? This kind of pattern here, like one large distribution here and one large distribution here. The way we're actually going to do that is we're actually going to apply a animated procedural map to this sphere primitive here, and animate that over time. So it's literally going to be a black and white animated map, so therefore as the map changes, particles are going to be positioned and also flung out. So therefore not only are we going to be using this animated black and white map for the particle placement, but also for the speed as well. So therefore where the particles are most dense and strongest, we're also going to have the most speed. So we're going to have like a large trail coming out here with some kind of third party trails coming out as well, which will basically create this, like I say, this U shape coming out of this sphere as well. Okay, the next thing we basically need to do is we need to obviously bring these particles back down to Earth after they've been ejected. So therefore the next thing we need to implement is, let's drop in a gravity space warp. Now I'm going to create this in the camera viewport or in the top viewport. Now the reason behind that is because these kind of directional space warps, specifically gravity and wind, are basically orientated in the correct direction when you actually create them, depending on what viewport you create them in. For example, if I create it in the camera viewport, it will basically point downwards. If I create it in the top viewport, it will create downwards as well. However, if I create it in the left or the front, I'm just going to create a new one here. Don't do this, let's just create this one that we've actually got in there at the moment. So if I create it in there, you'd see the direction it's actually travelling in now. So always bear that in mind when you're actually creating these guys. So I'm just going to cancel that and just leave this one guy up here. Next thing we need to do is we need to just set some properties within this deflector. So we obviously need the particles to bounce as soon as they hit the deck. However, we don't want them to carry on bouncing like, I don't know, ping pong balls or anything like that, so we don't need them to go, you know, bounce, 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 you know, indefinitely. So therefore we just need to drop the bounce value down to about 0.15. We're going to have a fair amount of variation for, well, the variation value, the chaos and the friction, and for that we're actually going to set 25% for the variation, 25% for the chaos, and we'll add a fair amount of friction in here as well, basically because, referring back to our reference, these guys literally hit the deck and then shatter off, and then literally on the second bounce they're pretty much stationary. Okay, right, so that's pretty much the majority of the stuff that we actually need to do in the viewport. So the next thing we need to do is we'll actually design the emission materials for the sphere speed and the sphere emitter objects, because we obviously need these guys to tie in, i.e. the emission strength is directly related to the placement. We're actually going to use one main procedural map and then instance that across between the two materials. So let's just create that now. Let's just create the one procedural map, and for that we're actually going to be using a cellular map. Now I'm actually just creating this within its own slot, and we'll instance it across to the other materials in a second, because obviously particle flow needs to reference the material that's applied, not just the map itself. So you can't obviously apply a map directly to an object. You obviously it has to be nested within a material. So therefore, let's label that. Let's call that Spark Design. Okay, and then what we need to do is we need to make sure that the mapping is correct, because at the moment we're basically just using object XYZ. Now the reason I'm going to change this to explicit map channel is quite simply because the XYZ coordinates will be, if I applied it directly to the object, we're using this guy here, object XYZ, if I animated the W offset, which I am going to in a second, the map would basically travel vertically. So it would literally have Z, Y and X offsets. If by changing it to explicit map channel, we are basically just doing, in essence, a 2D map. So that gives us the opportunity to use this W offset here to, in essence, create a phase. The reason being is because there is no actual phase value within this procedural map itself. Like for example, other procedural maps such as noise have a phase offset or have a phase animated phase value, which can basically cycle through the map itself. However, this particular one doesn't have that. However, a nice little trick is to actually animate this guy here over time. So therefore, let's quickly just do that before we do anything else. So what we need to do is we need to scrub forward to frame 100. Make sure we have auto key enabled, and we make sure we've actually got the linear keyframe type enabled down here. So make sure you have actually chosen this guy. Reason being, otherwise we'll actually have the value will ramp up and ramp down in strength. So therefore, at frame 100, what we need to do is we need to set this. Let's set that to 5. Okay, so you can see this change straight away in here. And if I just scrub through, you can see it cycling, but it's not actually offsetting left or right like it would do if I amended the U or V values here. It's actually cycling through, creating a kind of pseudo phase effect. Okay, so the next thing we want to do is let's just turn auto key back off, so make sure that's turned off, and I'm just going to colour this second division colour here, and I'm just going to copy over the top of this grey one, so we've got a lot more kind of contrast in the actual map. Alright, so I'm just going to scrub down here and let's just start designing the rest of our map. The first thing I'm going to do is I'm going to reset the size of this guy, so I'm going to set this to, let's set that to 0.8, and to add some additional detail I'm going to turn fractal on. I think I'll leave these values as is, it's got enough iterations in there, and I'm going to just drop the spread down to 0.3. So it kind of pulls this division colour up into this cell colour. If I actually amend this, you can see exactly what happens. So obviously we only want, well, the particles are actually going to be born where these white areas are. So if I just scrub through, you can see it just flicking on and off like that. So this is literally where the particles are actually going to be born. So we just need kind of this like sporadic ejections of particles going 360 degrees around this sphere. So with that guy sorted, all we now need to do is assign it to our two spheres in here. So the first thing that we'll do, let's basically let's set up the emitter. So let's just call that emitter exactly what it is, and I'm going to assign it to the sphere emitter object. Okay, so the next thing we need to do is because we need to sort out some clamping of this map, add in an output map here. Let's call that emitter control. Okay, and I'm going to instance this guy into this map here. So I'm going to just drag and drop that in there. Now it won't update because there's a redraw issue. Going to turn off show and result and then turn it back on again. So to control this, I'm just going to enable this enable color map checkbox here, pan down, and then to clamp off the edges, I'm just going to turn show and result off again. So we're able to see what we're dealing with here and be able to compare it with the original, which is obviously this guy here. I'm going to drop in an additional point just anywhere on this curve, go back to move, otherwise next time we click in here we'll obviously add in another point, and then I'm just going to reset these values in. So I'm going to drop that down to 0.25 on the X, and then I'm going to drop that all the way down to 0 on the Y. Okay, and the next thing I want to do is because we've got a pretty harsh edge here, I'm going to pull that in a little bit further by changing it to a Bechet corner, and then drag this across, I'd say just before the edge. If you notice, I'm not actually dipping down below this line. Make sure you don't, otherwise you will in essence get a negative value. You see that there, ducking down? So make sure that that's actually above there. So that should pretty much do us. Okay, so what I basically need to do now is do almost exactly the same thing with our other material. So this guy over here, so this one I need to call, let's call that speed, and then assign that to the sphere speed object in our scene. Okay, and same principle as before, I'm going to create an output map in the diffuse slot that I'm going to call speed control. Yep, and then let's instance this guy across to here again, and then the next thing I need to do is simply enable the color map in here. I'm going to drag this guy out, let's say to about there, and then to get these kind of nicer vertical peaks like we've seen in the reference, I'm going to change this point at position 1-1 to a Bechet corner, and I'm just going to pull that out to about there. So that's going to strengthen the whites out. You see that change up there when I did that? Pull that across a little bit more. Okay, so what we end up with is this type of resulting map as I scrub through. So you can see this. So in essence, this guy here is driving the particle emissions, this guy is driving the speeds, and a lot of this information here is obviously lost, and that's actually intentional so we don't get too many individual trails coming off it. Otherwise we'd have like 1, 2, 3, 4, 5, 6 trails coming off here. We only want like 1 or 2 flying off at a time, which is obviously what we saw in the reference. So therefore, when it actually comes to rendering, like I said, we'll have one or two trails coming off. If you actually want more and larger ones, then obviously all you need to do is amend these color maps and also amend the size values or adjust the iterations in this map as well. So obviously something you can do at a later date. Okay, so while we're actually in the material editor, what we'll do is we'll set up the sparks material. So in a new swatch, let's label that guy sparks, and because we're going to be assigning material IDs to it to create like the kind of glow around the sparks, let's change the material effect ID here to 1. Okay, and then we need to basically make this guy self-illuminated by using a map, so therefore we need to turn this guy on as opposed to just using a numerical value. So we obviously need to change the particle material over time, so therefore what we'll do is we'll use a particle age map in the diffuse slot, and I'm just going to scoot back up here. I'm just going to instance this straight across to the self-illumination slot, so therefore whatever we do in this guy is obviously going to be applied to the self-illumination at the same time. So back in here, and we obviously need to change the colors based on the particle age. So the first thing we need to do is let's just change the color for the birth. So that's going to be RGB 255 215 137. So we've got a nice kind of slightly desaturated yellow in there. And then the next color we basically need to use like an orange, which is going to be a 255 120 50. And then finally in color 3 we're actually going to have slightly dark orange, so 255 90 30. So that should do it. We also need to push this orange up a touch, so it basically starts changing color quite a lot sooner. So let's take that to about 15%, and then I'll bring this dark orange in a little bit earlier as well. So let's take that to about 75. Okay, so that's pretty much what we need to sort out in our material editor all done. So I'm just going to close that now, and the next thing we need to do is we just need to jump into particle flow and start designing our system. Go to our create tab, and I'm just going to go to the standard primitives menu here, pull that down, click on particle systems, and I'm just going to create a PF source icon in the scene. Doesn't really matter where, because we're actually not going to, the icon's irrelevant for this particular system. So I'm just going to drag this out as well before I start amending some of these values. Okay, so what I want to do is I actually want to see everything in the viewport in this particular instance. I'm just going to take that back to frame 0 because obviously we've got particles born there. I'm going to increase the amount of the percentage in the quantity multiplier group here. So I'm going to increase that to 100. And this particle amount upper limit I'm actually going to increase. Now the top end one on a 32-bit system is 50 million, so even though I'm working on a 64-bit system, I'll actually increase that up as well. So, and the integration step, I'm actually going to leave that. I think for particle accuracy we'll actually have the viewport, so we can actually see what's going on at render time as well. So I'll actually have that at half frame as well. When it actually comes to rendering, I'm going to leave this at half frame so we get some nice kind of subframe curved trails in our trailing sparks. Okay, so with that set up, what I'm going to do now is click on particle view, and that will bring up our particle view canvas. I'm just going to bring that in there. Okay, just scale that down so we can see everything. And the next thing I'm going to do, I'm just going to bin this description. I'm also going to bin this depot because this system is going to be quite big. So if you've got a larger monitor, I'm only kind of working on a small monitor here to keep obviously the download screen size pretty low. So I'm just going to drag this guy out. So if you've got like a larger monitor, then obviously you might want to use the depot to drag out operators. I'm just going to use the right click menu and drop in a material dynamic in there. And then I'm going to open up the material editor again and just drag in this sparks material into this material dynamic operator. Okay, so the next thing we need to do is set up this event 01. Let's actually rename that. Let's just call that Sparks, capitals on, Sparks Birth Flight. That's exactly what it is. And I'm actually going to set the emit start to let's set that to frame 1, and then let's set the emit stop to frame 80, so that the sparks which finish ejecting from here have a little bit of time to actually hit the deck before the sequence finishes at frame 100. Okay, so next thing we need to do is we need to bin the majority of these operators in here. So I'm just going to kill, let's get rid of the position icons. We don't need that anymore. We actually don't need the speed icon in the speed operator in there anymore either. We'll leave rotation, and we'll leave the shape operator in here as well. So I'm just going to reorder that. Okay, so I'm going to change this guy as well. I'm actually going to change that to geometry, so we can obviously see what's going on. Now, I'm just going off a tangent a little bit. The reason I actually dropped this material dynamic operator up here and not actually in this group is quite simply so this operator affects the entire system. Okay, so we don't actually have to drop this in every single event that we create next. Alright, so with this we've actually got 200 particles being born between frames 1 and 80. However, we cannot obviously see them in the viewport at the moment, quite simply because we don't have anything to determine where their positions are. So I'm just going to pull that back there. Okay, so what we need to do is obviously implement that. So I'm going to drop in a position object operator. I'm going to stick that between the shape and the birth operator, and what I want to do is I actually want to use the sphere emitter object in the scene, tell it that it's an animated shape because obviously we've got an animated material applied on there, and we basically want to say, okay, it's going to be positioned on the surface, but we also want to use the density by material with the grayscale option set here. So obviously we can choose various different options, like for example grayscale and opacity, red, green, blue, opacity only, or grayscale. So you just want to use grayscale here. However, we also want to make sure that if there are any particles where the system can't actually fathom where they need to go, we need to tell the system to get rid of them. Okay, so we need to obviously set a size in here. So let's make sure we've obviously got that in here as well. So let's actually set that to 1.5, and I'm just going to zoom in. I'm just going to go to the front viewport. So if we scrub through the sequence, let's just bring the material editor in. We'll be able to see when we start seeing some of the dots in here, we can basically start seeing particles being born. See some of these guys flash up. There we go. Okay, so the next thing I'm going to do, I'm actually going to increase this particle amount here by adding in a spawn test of all things. Actually, that's not drawn correctly, so I'm just going to close that, and I'm going to reopen particle view. There we go. The reason behind this is by adding 100 offspring in here, not only does it obviously add 100 times more particles than there were originally, it also gives us the opportunity to basically add in a fair amount of variation in there. So I'm going to add a 25% variation in there as well. Okay, so when I come to scrub through, we can obviously see a fair amount of particles being born, and because we're actually having a variation for each one born now and then positioned, it actually results in a nice random distribution. I've actually got particle amounts turned on here, so you can actually see the amounts, how they're actually incrementing. Okay, I'm just going to go and turn that off. Okay, so the next thing we need to implement is, first thing we've actually saw through there is we've actually got tetra shaped particles. So let's actually go and convert those to cubes. I'll scrub through and make sure that's right. Okay. Right, so the next thing we need to sort out, I'm just going to increase the sizes here so we've got a fair amount of canvas to work with. And the next thing I say we need to work on is basically the speed of the particles. So for that, I'm going to literally drop right underneath this position object. I'm going to append a speed by surface operator in. Drop that guy in there, and then in the surface geometry I'm going to add in my sphere speed, and I'm going to actually set the speed value. Let's set that up to 5,000, and I'm going to stick a slight variation in there as well, only a value of 100. Again, same as before, I need to tell the system that it's an animated shape and it's basically using speed by material. Same kind of principle as what we've actually got in this position object operator here. Okay, that's pretty much it for this one. Let's just actually drop in a very small amount of divergence in there as well. So when we actually come through to animating this guy, you can see them being flung out based on direction. So you can see straight away we've actually got this kind of U shape, which is basically driven by these kind of small kind of radial gradients within the cellular map. Okay, with this guy sorted out, let's basically add some scale variation within our system. So for that, let's add in a scale operator in there. Now we're actually going to add in a couple of scale operators in here. One we're actually going to use to set the general overall scale variation. So for that, let's add 100 in there for all axes, and then we're actually going to add in another guy as well, just to add a little bit more variation as well. So we're actually randomizing the randomized particles, if you will, and for that we can set the type to relative first and drop this down to 75% for each one, and then we'll add in a 25% variation as well, which basically will push it up to between 100% and about 50%. So therefore we're going to get, like I say, for those guys which have gone up to, like for example, 200% of their original size, we can obviously vary those around as well. So we've got a fair amount of random particle scales in here now, as you can see, within these particles, which are obviously emitted from this animated geometry. Okay, the next thing we need to do is we need to basically add in some spawning in here to create these kind of smaller, finer particles come off here. So to that, I'm going to make sure I'm at frame 0 to make sure that we don't actually accidentally create any adverse spawning in there at this particular point. I'm just going to turn the system off, okay, and then add in a spawn test. I'm going to drop that in. Let's drop that in above the rotation operator here, and then I'm going to set the amount of offspring, sorry, the spawnable amount here. I'll set that to 50% of the original. I'm going to set the amount of offspring to a grand total of 2 for each particle, and then have 100% variation in there. So remember saying when we actually looked at the reference, we only had like a couple of, we had like the main trail coming off, and then we had like a couple of additional child particles coming off as well. Okay, so this is this kind of fine spread that we actually saw in the reference. Alright. Okay, so for that, what we're actually going to have is we're going to drop down the inherited speed. Let's drop that down to 50% with a 25% variation, and we'll have a pretty nice wide divergence in there. So let's drop a divergence in there about 35 degrees. Scale, going to drop that right down to 50% and then have a 50% variation in there as well. So that gives us an overall spread between 0 and 100%. Okay, so when it comes to, let's just re-enable the system. This might slow down slightly while we're actually doing it. So we're getting this kind of nice spread coming out from our system. Okay, let's just bring the material editor up so we can actually see this update. I'm actually going to turn on this show end results so we can see exactly what's going on in our materials. So make sure you've got show end result enabled here and here, which will aid viewing it in the viewport and also aid the particle system to update. Let's see that updating now. It's looking quite good. Okay, so obviously what we need to do now is we need to deal with gravity to obviously bring these particles back down to the ground. However, the smaller particles, what we want to do is, because they're obviously going to weigh less, we obviously want to pretend or give the illusion of that they have different resistance to air than the larger ones due to their size. So therefore, what we can do is we can actually split these off to a separate event that has different gravitational properties. So to do that, we'll add in a scale test, this guy here, and I'm going to drop that. Let's drop that below this rotation. Oh, I just accidentally deleted that, so let's just go back to there. I'm going to drag that over to that side because we'll build the event over this side. And then what I'm going to do is, within this scale test, I'm actually going to say, right, if the particle value is less than 75% of its original size with a variation of 10%, I'm going to send these guys out to the next event where the gravitational properties are going to be slightly different to the ones within this one. So speaking of gravitational properties within this one, let's just add that in as well by adding a force operator, and then we'll add in the gravity space warp. And then to get them to drag down a little bit further on what I think we're going to achieve at the end of the day here, they're going to come down like that. What I think we'll do is we'll actually increase the amount of influence, because the speed within this guy is quite high. So therefore, let's just take that down. Let's increase that. Let's increase that to 2000. So when we actually come to scrub through it, we get a nicer gravity. Let's just bring this material editor back up so we can see what we're doing. Okay. Right. Okay, so the next thing we need to basically implement is a couple of things to basically kill or affect the particles. So the next thing, let's drop in a delete operator to say, okay, right, these guys have got like a finite lifespan. They can either literally die almost immediately, or die within, say, for example, a couple of seconds worth of time. So let's say by particle age, let's say the lifespan is, let's say, 50 frames with a variation of 50 frames in there as well. So in essence, they're going to actually between 0 and 4 seconds in essence, if we're dealing with the 25 frame time code, which in this particular instance we're not actually dealing with NTSC, so that's obviously a different frame rate. Okay, so the next thing we need to implement is a collision, and for that let's just drop in a collision test, and let's drop in our deflector space warp. So then when these guys actually hit the deck, just scrubbing through, obviously calculations have taken a little bit more time now. You can see them bouncing around a little bit, and then maybe a couple of times if that, and then come into a virtual rest on the surface. And that is obviously driven by the values we're obviously set in our space warp. Okay, so that's pretty much sorted now for our sparks birth flight event here. So the next thing that we'll do is we'll let's set the properties up for when we actually have these sparks hitting this deflector down here. So for that, what we'll do is we'll actually copy this force operator. So let's copy that guy, and I'm going to instance it to a new event, and I'm going to rename that. Let's call that bounced sparks, and I'm going to wire the output of this collision test into the input of this guy. However, bear in mind that in our reference we actually saw a couple of things. One, as soon as some of these guys hit the surface, I'd say about 70-80% of them died straight away. They actually just shattered and died, or just died upon impact. So therefore we actually want to get rid of about 80% of these particles as soon as they actually hit this guy. So therefore I'm just going to drop in a new, where are we, delete operator in here. Going to get rid of that, we don't need that, and then add in a split amount test in here, drop that up to the top, and then say okay, we want to get rid of 80% of the particles as soon as they arrive into this event. So we don't need to calculate gravity or anything like that. As soon as they hit the deflector, they get parked into this event where 80% of them are deleted. So therefore if we scroll through now, we can see that in action. So doink, 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 doink. And you notice that they'll bounce. These ones that are remaining are bouncing off and bouncing once and then passing straight through the deflector, because there is no deflector within this event at this current time. So I need to copy that, and let's instance this guy in there as well. So let's drop that in there. This is going to update for a second. Okay, so once we've actually got that in there, what we'll do is we'll also drop in the same kind of lifespan. There we go. They're kind of all coming to rest on the ground here now. So let's copy that guy. I'm just going to drop back to frame 0 as well, and so they have the same lifespan. Instance that in there as well. And we obviously want to create these kind of fragmented trails as soon as the particles which don't get deleted on the ground. So let's quickly implement that by adding in a spawn test, dropping that to the top here, and then what we need to do is let's just get rid of the original particle, which is obviously the delete parent here. We'll set the spawnable amount to 25%, so it's only 25% of the total amount which passes through here has the parent deleted, and also additional particles, let's say 5 particles born. Let's actually have a fair amount of variation in there as well. Let's crank that right up to 100, so we get basically between 1 and 10 offspring in essence. Okay, so we want to set the offspring. Let's set the offspring's inherited speed, let's say about 35%, and we'll add a variation of 25%. Actually, no. Let's set the inherited to 25, and a variation to 25 as well. The divergence will actually set there's quite a wide 45-degree angle, and the size, because we're obviously dealing with fragments, we obviously need it to be like 50% of its original size with a 25% variation. So when these guys hit the deck, let's just scroll through gingerly again. You'll notice that we start. Actually, we need to see some of these. Let's have a look at some of these. There's geometry. See, some of them break up. Let's just switch to camera. Let's have a look. See, a lot of them are actually being deleted, but some are obviously fragmenting out, like for example these guys that have just done it down here. Okay, so that's that one pretty much sorted out. The next thing we need to do is obviously deal with the scale test here. So to do that, we can literally use a fair amount of the stuff we've obviously got already set in here. Now this is basically what we're dealing with here is in essence the same deal we're dealing in this particular event. We're actually not dealing with any kind of bounced sparks at this particular point in time. We're actually dealing with the smaller particles which are still falling, so therefore we can just grab this force operator here, grab the delete, and we can grab the collision here as well. Just copy that, and we can just let's just paste that in there. Okay, and then we can just set the force operator. We can just drop that down to, let's say about 1500. So the gravitational attraction isn't as strong on these smaller particles than it were on the larger ones. So therefore that can get wired into there. The delete, we're actually going to change that as well. We're going to change that to 25 frames for the lifespan, with a variation of 25 as well, so they don't live as long as the larger counterparts. Okay, as soon as obviously they hit the deck, as before, what we can do is just instance in these guys here. So copy that, instance those in as well. Okay, so that as soon as they actually hit the deck, they bounce back up once. But we also want the same deal as before. We want 80% of these particles to be deleted immediately. Okay, and I'm just going to change this to geometry for each one, and that is pretty much our system setup. So when it comes down to it, you can see these smaller particles are actually dragging now more than before. Got some nice bursts of particles emitting from our emission object, and then the ones which are glowing and still stationary sat at the bottom, and they will delete over time as well because of these delete operators here and here. Okay, so that's that system pretty much set up. The last thing we need to do actually before we do anything else, like with regards to setting up some post effects, is we'll just change this motion blur to object motion blur. Now, same deal as before within the angle grinder tutorial, we're using multiple pass techniques to generate the trails. Reason behind that is because the glow otherwise will basically only apply it to the central particle, not to the motion blur itself, because object motion blur deals with, in essence, a multiple pass method of motion blur. The post effect will be applied for every single pass or every single instance of the object. Okay, so with that implemented, let's just kill that. I'm just going to minimize, actually just close that guy, and I'm going to go across to the let's go to the effects panel here, and I'm going to create a lens effects effect. I'm going to drag that in there, and then what I'm going to do is actually use multiple glow effects to create the kind of nice spark glow around there. Now this is going to be quite tight around the particle, and same deal as before within the angle grinder one, we're actually going to render this out considerably bigger than what than the footage we're actually going to have at the end of the day. Reason behind that is because the glow is limited to pixel sizes, which it's very, very kind of finicky. It's a notorious problem when it's coming to adding these types of post effects within 3ds Max. I would seriously suggest, if you have the opportunity, to add these kind of effects in the comp, quite simply because you will get a lot more control, you'll get a lot more color correction and enhancements of glows and blur effects, that kind of thing. But this kind of works in a pinch, quite simply because the scene renders out very, very fast anyway. So for that, what I'm going to do is create 3 glow effects. This first one, I'm just going to add that in, and then actually, you know what, I think we'll scrub forward a bit. Let's just bring this material editor back up so it updates. Okay, there we go. There's an update issue because of these maps used, the output maps used in here. Okay, shove that out of the way, and I'm just going to render out a single frame, and for that I'm going to apply 1600 by 1200, so that obviously changes it automatically. Close that, and then I'm going to turn on interactive here, and this will go ahead and render out one scene. It's just updating the particle system. So that's our particles enabled here, and I think we've actually only got the, yes, let's make sure we've obviously got the motion blur set to a fair amount of samples for long frame duration. So let's do the entire frame. I'm going to stick 20 samples in, so it kind of removes any kind of differentiation of multiple passes between the particles. So it's going to take a little bit longer to render while it's working out the additional samples, but not that much. You see, that's nice and smooth now. So okay, so with that set up, what I want to do now is I want to amend this glow effect that I've added in there. So I'm going to rename this first. Let's call that glow small. Okay, and then I'm going to change the material ID. So I'm going to enable that, and as soon as I enable that, it basically decides that it needs to update, quite simply because the material ID channel has not been filtered across into the lens effect, and you can see it updates straight away. Switch back to our parameters tab here. I'm going to drop this size right down, so we're going to drop that down to 0.001, which is the lowest value we can actually do, and you notice that's gone straight to white. And this is the limitation that we achieve, that we have. This is the smallest value that you can actually physically do in this glow element, quite simply because it's we're dealing with single size pixels here that it's trying to affect the glow on. Okay, it needs to obviously have some form of information to actually work with. Okay, so the actual amount of intensity, I'm going to drop that down to about 90, and I'm also going to say, right, we need to use source color, but we need to use about 90% of the original source color, which is obviously this kind of yellow. However, that's obviously not yielding quite a nice result, so therefore let's just amend the color slightly and mix it with a touch of orange. So for that, let's add in an RGB value of 255, 95, 65, and you'll see it update immediately within this setup here. Okay, and that's pretty much it for this particular one. So let's add in another one, and then set that to material ID of 1 as well, and that will update in the viewport, sorry, in the render immediately as well. Same deal as before. We're going to set the size this time. Let's set that to 0.01. So that's going to shrink that down. There you go. I'm going to rename that actually. It's called like glow medium. The intensity, I'm actually going to drop that down to about 60. And I'm going to set the use source color, which is obviously going to use the color from the previous glow as well. I'm going to set that down to, let's drop that down to 80, and I'm going to set the radial color to the same color swatch as before. So for that, I can either dial it in this color selector here, or I can literally just go back to this small one here, right click, copy, go across to the medium one, and paste it in there, and that will update that straight away in our effects preview. One more to do, drop another one in. Let's label that glow large, set the material ID as before, skip back to parameters, going to drop the intensity down this time. Let's set that to 70, I think. Okay, use source color, I'm going to drop that down to 50, so when it actually references this radial color, which we're still going to drop in there, it's a lot more redder on the sides of the glow. Set the size down properly. Let's drop that to 0.05, what it was supposed to be. There we go. It's got a nice kind of tight glow around the edge now, so that's looking a lot better. I think maybe we could do with, I think actually no, I think I was going to drop one more glow in there, but I think actually that kind of works nicely, bearing in mind that what we're going to have at the end of the day is in essence the animation sequence at half size. So I think that's pretty much it for this sequence, so let's just go and render out a quick test. So I'm going to render this guy out, and then what we'll do is I'll just quickly pause the recording on here, and we'll come back and have a look at it when it's finished. I'll see you in a second. Okay, so our render's basically finished. Now what I've basically done is I've saved this out as the electrical explosion sparks finished max scene, so that's will obviously be included with the video tutorial as well. When it actually came to rendering, what I actually did was, because you might actually notice some of the particle emissions being incorrect, like for example they were just kind of trickling down here. That is basically due to an error in the output map. It's nothing that we've actually created here. It's basically an issue with the system itself, with 3ds Max itself. It basically wasn't piping this through. Remember we had the redraw issue here. Same kind of principle when it actually came to render time as well, which is the reason we had to have this material editor up when we were scrubbing through. So okay, so what I basically did to get around that is simply just save the scene, close Max, load it in again, and render it out, and it came out perfect. Okay, so I'm just gonna try and show you the animation. Obviously because I've rendered it out big, it's not fitting on this particular screen. I've rendered it out at 1600 by 1200 as mentioned before, and obviously the RAM player is sitting a little bit on the big side, so you should be able to see these guys here. So there we go. So we've got a nice kind of particle emission coming out here, hitting the deck, one kind of like little bounce with a fragmentation, the majority of them being deleted, and that works pretty well. The motion blurs about right. I'll just get this across here so I can pause that guy, so you can see these guys kind of trailing off, fragmenting as they hit the deck. Got some nice trails here. You can see again some kind of fragmentation within the trail. Now obviously that's due to the amount of motion blur samples that we've got set in this guy here. Obviously we can increase that, but obviously that will increase render times as well. So obviously bear that in mind when you come to rendering the sequence. Okay, so that's pretty much the end of the tutorial. However, what can we actually do to take the thing further? Couple of things. One, basically, obviously we can, as mentioned previously, add in, let's say at the beginning here, like for example when we have these kind of bursts of sparks, we can obviously add in a blue flash akin to what we've got in the reference material. Now to basically do that, what you could simply do is animate an omni-light or a glowing object in there, which is basically taking this animated cellular map into consideration, drop it in with a, say for example, a color correction, so you can instance that across within the color correction map, and then apply that to a renderable version of the sphere, and then either comp it on over the top or render it off within one pass, and then apply glows to it using additional lens effects, so therefore that kind of flashes accordingly on the right side when you've actually got these corresponding sparks. Obviously you might need a fair amount of glows to obviously get the thing to stand out. Okay, that's one method. Second thing is, obviously if you notice within the sequence we've got almost constant stream. So we've got a burst there, a beat, and then a burst there, and then it's almost constant burst. I love that little one that goes up there, brilliant. It's almost constant sparks, so you might want to actually break this up even further. Now because we're obviously animating the Z offset linearly, going from frame 0 to frame 100, you might want to kind of either animate, let's just bring this material back up, you might want to animate this guy here so we don't see any whites in the material swatch. However, an easier way of doing it, if I just undo that would be to literally mix this cellular map with an animated noise map, for example, which will in essence mask off the white areas here even more sporadically throughout the entire sequence. So that will kind of break it up even further. So what we'll end up with at the end of the day is in essence a burst, a longer beat between, for example, this burst here and the next one, and then maybe only about 2 or 3 throughout the entire length of the sequence. Obviously this is kind of more akin to, for example, a transformer that's blown out and is just randomly sparking, as opposed to this one, which is a lot more kind of like welding sparks, especially with that burst there. So obviously design and time the sparks to your own needs and to your own kind of simulations at the end of the day. Also, you might actually want to speed the system up, for example, increasing the gravity and increasing the speed of the particles as well, depending on the scene scale and the type of proximity to surfaces. For example, this is basically set up, for example, like a transformer or a pylon that's kind of mounted a fair few feet up. So these sparks are obviously designed to be quite big. If you actually want them to be like, for example, welding sparks that are close, proximity surfaces, and they're quite small sparks, you obviously want to make sure that the sequence runs considerably faster. Like, for example, if I just drag this guy up here so we can obviously see what's going on, I'm just going to increase the frame count here. I'm going to up that to 60 frames per second and then play through that. So when I play through that guy now, it looks a lot more kind of like those welding spots that we saw in the reference materials. Very fast, very vigorous, very fast lifespans. But obviously, in essence, bear in mind that this is literally just a frame increase. So obviously, when you're actually designing your system, make sure you do it accordingly. For example, you can actually double the amount of gravity, double the speed, and that should pretty much give you a similar kind of speed effect. Okay, so I hope you've enjoyed this tutorial, and I'll see you on the next one. Thanks very much. Cheers.